Welcome everybody for the Step Taper sessions on advanced strategies for intelligent data application on SAP Cloud. I'm Shraddha and I'm from HANA Cloud Product Management team. And I'm working on topics like HDI and application development. And now I would like to hand it over to Volker for his introduction.
Thanks, Shraddha. Volker Söcker here. So I'm working on XSA, XSC, and HANA PM, as well on HDI BAS. And with us is also Jonathan.
Exactly. So my name is Jonathan. I'm from HANA Cloud Development, and my topics are also HDI, HANA tooling, especially developer tooling. And so we three are here today to tell you a little bit about some tips and tricks on intelligent data applications. Our agenda for today, we first start with some deployment parameters that can help speed up your deployments when using the HANA deployment infrastructure. Next, Volker is going to tell a little bit about how to use the HANA Cloud Fabric virtual tables in your applications. And as the third topic for today, Shraddha is going to talk a little bit about interesting HANA tooling features that might be useful when developing applications. And in the end, we'll have some time for Q&A. And with that, I'll start the topic on the deploy parameters. Next slide, please. So when you do a deployment to HANA, for example, from a CAP application, the underlying technology that's used to write the objects into the database is HDI, which stands for HANA Deployment Infrastructure. And so the HANA deployment infrastructure by default is optimized for standard deployments that work in the majority of cases quite well. Of course, there can be some scenarios where these default settings are suboptimal because of the particularities of the scenario. And to get better results when deploying, so typically faster deployments, there are some parameters that you can set in your deployments to get significant speedups. And I'm going to talk about some of these parameters today. The first parameter that's very interesting is a parameter called try-fast table migration, which can be used to migrate tables to a new version. And I'll get into the details what this does, but safe to say the scenario that benefits most of it is if you have large tables with many columns or tables that contain a lot of data. And here you can see significant speedups. The next parameter that I'll touch upon is called skip unchained expansions, and this can be particularly useful if you have complicated modeling scenarios or other container scenarios that access many different other schemas through synonyms. And in that case, this can significantly reduce the scope of a deployment. Another parameter is called validate external dependencies, which is a useful parameter to know about if you are having scenarios involving virtual tables, so remote access, federation, replication. The fourth parameter is called optimize file upload, which can be very helpful if you have lots of design time files, but only small changes in the design times in one deployment. And lastly, I'll touch upon the trace parameters that are here in case you're running into issues in your deployment, or you just want to know more about what's happening in the deployment. You can enable tracing. All right, and this is just for your reference. If you want to set these parameters, there are several ways. One is you can set an environment variable called HDI deploy options. You can also use a command line parameter when starting the HDI deployer library, or if you're using MTA deployments, you can also add the parameters to your mta.yaml file. All right, and with that, I will do a quick demo of what these parameters do. All right, I have here my business application studio. And in here, I have a simple CAP application. It's basically the standard bookshop example, to which I have added a few files. And we'll see what these files are later. So I'm going to use the SAP HANA project view to start the deployment. So let's do that, see what happens. As you can see, it starts the deployment. Right, so it's processing some files, it's connecting, it's locking the container, and now you can already see it's writing some files. And so this writing of files, it seems to be taking a long time, which is already something that prolongs your deployment time quite significantly, right? And so what you can see is the overall deployment took about 23 seconds, but as you can see, it said no make necessary. So it didn't actually do anything, right? But it still took 23 seconds. So the question is, what happened? Well, the reason is that in my design time files, I have a really large file. So I added some additional book data. And when a deployment is started, HDI tries to figure out what has actually changed on the database to only then deploy what really has changed. But by default, what happens is this check whether something has changed is done on the database side, meaning that it has to upload the whole project to the database first and then try to figure out what has changed. And especially in the case of large files, this can take a long time. And so if you have a scenario like this, there is one parameter that can help you, which moves this check whether something has changed from the server side to the client side. And I'm going to show how to do that in the mta.yaml file because I'm using MTA deployments. So here I have my deployment module. And what I'm going to add is I'm going to add some properties. And in my properties, I'm setting the HDI deploy options. And so the first parameter that I'll show you is called optimize file upload, which is exactly the parameter that in the end then moves the detection of the changes from the server to the client side. All right, now I've set it. And so we will just re-trigger the deployment. All right, so it's doing the same again. It's synchronizing the files with the container. And as you can see, the writing files basically took no time at all right now. And so because of this simple change, the deployment time came down from 23 seconds to 6 seconds. Right? And so if you have these cases, then it's easy to see why this can speed up deployment significantly. All right, let's continue. I have my data model here, which is, like I said, the standard bookshop example. I did add another table where I have a summary of the book. And these summaries can get quite large. And this is why I defined it as a large string. All right. Now, let's say, so this table is already deployed. And we can check that really quick. All right, so here I have the bookshop details. And right, you can see that here there's a bunch of data in there already. Right, so let's see. Now assume I want to add here another column. Say I want not only the summary in the book, but maybe I want an author. Right, so okay, fine. I'll just add this, and then I deploy it to the database again. And so it's starting the deployment again. It's synchronizing the files, which is still fast. And now here you can see it's detected there's a change to the book details. And now you can see it's waiting again. And why is it waiting? Because by default, the changes to tables are done by creating a temporary second table and then copying over all the data. And this is indicated here, right? The migration via a shadow table. And especially since there's lots of data in the table here, the migration via shadow table takes a long time because all of this data has to be copied over, right? And so this can also be a problem for deployments. And so let's wait for this to continue, and then I'll show you what else we can do about this. What I'll do is, well, I'll go back to my mta.yaml file. I'll just let this run. Eventually, it'll continue. And so I'm just going to add another parameter. This time, it's called try fast table migration. And what this does is it tells the database to try and find or detect the type of change that was happening, and find a SQL statement that can, instead of copying the whole data, in the case of my data model here, I just added a column, right? And so instead of just copying the data, it should just add the column. And we can see that this works. I'm just going to remove the column again. And instead of copying the whole table, the next deployment will actually just execute an alter table statement and remove the column again. Right? So we start the deployment again. And afterwards, the deployment should be much faster. As you can see, it's already done. Took no time at all. And here you can see the table structure was changed, running fast migration. So it truly just did an alter statement. And so this has also the potential of saving significant time during the deployment. All right. In my data model, I have added some synonyms to an external schema. Right, so I have 4 external tables in my project, and I have also created some entities in CAP and some views on top of those. And so now let's say I want to add another synonym. Right, so let's say I want to call this tab 5. And it should point to tab 5 also in the remote user schema. Good. Let's deploy this, see what happens. All right, as you can see, it failed. So what's going on here? I can look at the error here. And it says the container's object owner is not authorized to access this table that I just added. And so now I'm thinking, well, I'm pretty sure I have a grantor file that should grant this, and I can see in the log, okay, it's actually processing that grantor file, but apparently there's something missing. But, you know, how do I figure out what is exactly missing? And for that, I can enable the next parameter, just say, okay, I need more information. So I just say, let's trace this, see what happens. Okay, I start another deployment. And so it's running it, and you can already see there's lots more information that's being printed here. And so what I'll do is I'll go back to the grantor service and see if I can find more information here. All right. And as you can see now with the trace, it actually prints all the different statements that it's executing, right? And as you can see, apparently we're only granting privileges on tab 1 through 4, but not on the 5th one that I just added. Okay, I see. So that seems to be the issue. So for now, I'm just going to disable tracing again because I know what's happening. So I go into my grants file. And so I add more object privileges. This time, I'm going to add tab 5. And I'm also adding select. All right, now let's deploy it again and see what happens. Tap. That means, yep, I actually made a typo here. right, and in this case, if I just copy this over, let's try it again. Synchronizing again, writing the files, checking what's changed. And as you can see, now finally it succeeded because now I have everything I need. One thing that you might notice though is I really just added tab 5 here. Why is it doing things with all the other things in the synonyms? And as you can see, there's also a bunch of views here. And the reason for that is that HDI works on a file level. And since I have defined all my synonyms in one file, even if I just add one here, it processes all the other synonyms in the files and, of course, also the dependent object. And so the more synonyms you have in one file, the more you're affected by this. And so this can be fixed by another parameter, which is called skip unchanged expansions. And an expansion is precisely this. So when HDI starts a deployment, it takes one file and it expands the individual synonyms from that file. And like I said, by default, it deploys everything. But if you say, well, skip the unchanged expansions, then it really checks what of the expanded objects has actually changed. And so we can try this again. So I'm just going to say, well, maybe I don't need table 5 after all. So I'm just going to remove this and run the deployment again. And it's trying to detect the changes again. Right, and as you can see, right now it's really just changing anything that's related to tab 5, and you don't see any of the tab 3s and 4s here anymore. All right. As the final thing that I want to show today, I also have a virtual table that points via a remote source to a remote books table. So say I have another database with more book data, and I want to use this in my application. And right, so I also have a cap entity for this and a view on top. Now, say I want to add more information to my remote books table, which is this one here. So say I want to, add another column here, right? Say I want also stock information. So I add this here. So now my remote books table has 3 columns: ID, title, and stock. And of course, I need to change my data model here. So I add stock as an integer. All right, so I now deploy it. And so what happened? For some reason, there's an error. And you can see the error is that it's an invalid column name, remotebooks.stock. But, the question is what happened, because, I added this definitely here. Right? And the reason is because the virtual table points to a remote source. The changes that are behind the remote source are not automatically propagated to the database, right? So the remote source in my database still has the old definition of the table. So what I need to do is refresh it. And I can do that I can do that manually in the database via a procedure. Or if that's something that happens often, I can also add a parameter, which is called validate external dependencies. And if that parameter is set, HDI will automatically refresh all the remote sources on deployment, right? And so now I've set this. I start another deployment. And then once the changes have been detected, all right, good. Yeah. And that is about all I wanted to show. And with that, I will hand over to Volker for the next topic.
I take it back. Continue where you just ended up, which is now a new construct in HDI, which is called the Fabric Virtual Table. So you showed already that you have a virtual table, and we had the access to an external data source. Typically, that's either another HANA or HANA on-prem, maybe through Cloud Connector or to another HANA Cloud or to even another data source. Or recently, we also allowed ABAP data stack and see ABAP as a SQL source. And now we, inside HDI, and that is new, allow to also build up replicas, or not really caches, it's snapshots. So we have a copy of the data of the source. So depending on your volume, performance needs, and so on, and your update needs, you can have a remote view, you can have a snapshot of the data, or you can have a replica which live synchronizes the data from the source to the HANA Cloud where we are working in, and that in HDI. So that's what I'm going to show. There is a new syntax which is called shared and either snapshot or then replica. And you can even decide whether you want to have it page or column loadable, which means it stays on disk, the data, or it is in memory. And then you say on which virtual table. And what it does in the background, it will create for the virtual table we have either its own table where it replicates in or where it stores the data in. So at deployment time, we do this function in the background, and at undeploy, we take it away, which will allow you to enable and disable the replica while you're working, or you want to have a refresh of your replica, or you want to change the storage type. Some of these changes require alter capabilities. That's not done simply, so I will show you how to handle that as well. And we are looking a little bit in the code. So let's go into our Cloud Foundry site and the BAS environment. And this is quite a lot of things. So let's go. I have made a little tour to this code. So the first thing we need is, and I take that out here, we want to have a new construct, which is coming very soon but it's already available. So you can also add that. I will document that in the blog. So you can have a Fabric virtual table construct as well. So you will see that in my code in a moment. And then you have to have a plugin which is serving that. So for the next step, we are going to build our virtual table. So we have a virtual table. I take a person, and then I did here a quite complex scenario with a combination of config environment where I point to that. I will show you another way to do that in a moment. So we will we are going here. So what we mainly do is we will create a virtual table called VT person, which points down to a person's table. So I can show that as well. So if we go in my database here, I'm now in the database. I have an application in my remote source, which is called my application, and there's a table, and there's a person, and we have 3 fields here, and we have some data here. So Albert is here and Robert is here, and we have them on the side. So that's the definition how to get there. The next thing is we define also a shared replica on BT person. So we will have a replica running on our side. So once that is deployed, same thing as Jonathan just did, running through, we have this table. I did that before, so no big changes there. And we can now look at the target side. I have prepared that here. and we can be on the current schema, and we can first, it's another one I'm showing later, select star from, we have it VT person, and selecting that, run, and we should see, where's my result? I have to find the bar here. Where is it? There it is. So we see here, we have seeing both here. So how I'm sure that I'm seeing both here, I'm doing that as an admin to look a little bit what's happening inside the database. So I can see here, I'm looking inside some system tables here to see if in my Devtober folder with my table BT person, something there. And when I'm doing that, I will see that I have an auto-generated replica. So I see my table is an RTR replica coming from the other side. So how I can prove this, I can go to my remote source, and I'm going to my Albert Einstein here, and I just double him. So I make a 3 here and a 4 here. So I insert both of them into my database, 3 and 4, and then I'm going back to my VT person. So let's see what's now running here. And now I have all 4 there. They are now replicated. And the beauty is the VT table I have was before a remote table, and it's now switched, but the object didn't change. I did that under the hood, and the users of the table don't see other than the performance changed, that they are now getting either a remote or a local copy of the table. So there's a lot of things behind that to get that running. The most important thing I'm showing here, and I will write, as I said, I will write a blog on this, is this remote definition. And what you have to do is to allow that you have to have on your remote source, you have defined, you have to have the create virtual table and the create remote subscription rights to that. You have to add that into the table in your database, in your HDI container, sorry. And therefore, we have to go and use a cross-container service, a user-provided service. There is a user inside my BTP environment which has the rights to grant my HDI container the capability to do this. It has a special role which he has, or rights he has, and he will allow my container to define these special tasks here. And now my container is capable of building remote virtual tables and remote subscriptions to the data. And to show you how powerful that is, I made another one here. So just let me see if I have my console back. I'm just looking. No, I cannot find it back. That's here we are. So I made another table called tpart. So let's see what's in tpart right now. So we run that. It's disconnected. I have to reconnect them. So tpart execute has some data inside. So we truncate the data. Let's see how many data are now in. So it has now 0 rows. It's a script here. It's a massive table with a few values now coming in. And I'm using generator functions here. So in this time, I introduced 3 million values into my database here. I'm using a series function, which is inside HANA to do that. And I'm going on the remote side again here. So I'm going on my select statement, and I can see here now that I have access to these data as well, which I just created. So that's amazingly fast and easy to handle with large volumes even. So that's what I wanted to show.
Thank you, Volker. And now let's continue with the SAP HANA tooling features. First up, we have SQL notebooks for SAP HANA. SAP Build Code offers the notebook functionalities, which is similar to the well-known Jupyter notebook. Since Q3 2024, we have the SAP HANA tools have the notebook experience, which is helpful in executing SQL statements on the SAP HANA Cloud database. Next up, we have dependency viewer, which is a nice graphical view which displays the dependencies between the selected database objects and any other objects. And also when you have previously viewed a particular dependency data with certain filters or with the certain schema selected, that particular settings or that particular check is already saved in the cache. So the next time you want to make use of the similar filters or the similar changes, you can retrieve the data from the cache data and which will be retrieved for a quicker performance. And then we have SAP Container Manager, which basically helps in deploying, undeploying, and also recovering the artifacts from a bound HDI container service, and also reads the content from the current dev space. And next, and finally, we have the one of the Gen AI features that we have, that is the Intelligent SQL Assistant. So this is basically a conversational SQL which helps in converting the natural language into the SQL statement. This is very beneficial for citizen developers, and it also helps in reducing time in generating the SQL queries. Now let's see all of these features in action. Let me just switch back to my dev space. And first up, we will see the SQL notebook. So you can add the SQL notebook by adding the extension .notebook here, and you will have the code blocks here. And you see that I have already have a set of options ready here and set of statements that is ready for execution. So you can add a code block by clicking on this plus option, and this would basically generate a code block. And in order to connect to a particular database user, you have to select the code block to SAP HANA Connection Management. So since I have it ready, I will just go ahead and execute the ones that we have here. So first up, we have the list database connection. So let's execute and see what we get as a response here. So we have 50 options here, and I would just want to pick one of them. That would be the DB admin here, which is highlighted. And on click of this, or like when you click for another one, it would just highlight on that option. And right now I won't want to select this particular HANA instance. And then we can see if that was successful in the database connection. So let me just click on the current database connection, and that would give me the response saying that the database connection for this particular notebook is DB admin as a user. And also you can also do the close current database connection as well. Also for a quicker use, when you click on when you start the code block, you can type hash, which would give the options, the 3 options that you can execute here. Then next, we can see how we can execute some of the SQL queries here. And this has to be changed to SAP HANA SQL as the code block here, because we are executing SQL queries. So right now, I want to see the current schema from the dummy, and on execution, I would get the response saying which is the current schema that is selected. And also you can do furthermore executions, like you can also execute a procedure, you can create a table, and also do all the operations with respect to that table. So for now, I just did a select query, which basically selects all the containers from which is basically selects all the containers. And I'm also specific about which container I would want to view the data of. So on executing this particular line, I would see the data that is generated with respect to this particular container. For example, I can see the timestamp or which the container group is associated with. So that's all about the SQL notebook. And next, we will go to the dependency viewer. So in order to go to the dependency viewer, we have to go to the SAP HANA Database Explorer extension. You see that I have been connected to the Cloud Foundry, and I have logged into the Cloud Foundry, which basically retrieves the list of the HDIs and the HANA instances that I have. And here I would want to go to the dependency viewer, and you can do it by right-clicking on the particular HDI container and clicking on Open Dependency Viewer. which basically opens the dependency viewer that we have. And you can select the object as per your choice on schema or the type that you want. For example, if you want to just select the table, and also you can see the options that we have for the schema on the list here. So I have already have the dependency viewer where I've selected a schema, and also you can see that what are the artifacts that is generated. You can zoom in and zoom out as per your liking, and also you can have the buttons to do the zoom in and zoom out options. In case if you have lost this in the screen, you can also click on this option where which is fit graph to into viewport, which basically gets it back to the center. And you have options like locking the objects as well. So for example, you can hover over or move this particular object anywhere in case you don't want that. And if you have a bigger or the extensive dependencies, it's better to always lock it. And you can identify the lock by seeing this highlight over the lock option, and which would just lock the entire objects together. You can have further settings like choosing the graph depth, since we just have the graph depth as 1 and not more than 1 here, so you cannot see furthermore changes here. But if you have like a graph which has like more roots or more trees to it, you can change that respectively. And also you can check for the cyclic dependencies and also restrict graph to a current schema. And also, if you want to just look into one of the artifacts, you see this nice view on the side where you see the object that is selected and also the schema that is associated with that, and also the artifact type. It could be, for example, if I select this view, it would show the artifact type as column view. You can click on this open metadata view, which basically shows the metadata of the selected object. For example, if I just click on the metadata view, it would just load another tab, basically showing the metadata with respect to it. Up next, we have the container manager. So you can access the container manager by selecting F1. And you see that you can just click on SAP HANA Container Manager and you can open that right away. So SAP HDI Container Manager basically helps you in recovering the artifacts, undeploying the files, and deploying the files. So let's just start with recovering the artifacts. So here I have a set of tables here, and I would, if I just go ahead and delete one for now, just to show you the example on how you can do the recovery, and select the HDI that where the table was deleted. Let's see what the data shows. It shows that this is missing from the workspace. Now you can select this option and go ahead with continue. And you can click on recover, and you can see that this table is recovered and added to your workspace successfully. Next, let's see how we can do the undeploy of files. Let's refresh here and see what we have as an option. So you see that there are like a lot of files that is here, and I can select all of them together, and I will select this option undeploy recursively, which basically shows the dependencies that these artifacts have with one another. And on click of continue, you see that the dependencies of the artifacts together, and you can review it here. And then once on review, I will just click on undeploy, and this would take over, and also the operation is successful and the undeployment was successful. Now let's deploy the same things that we have undeployed, and let's select the option deploy here and select everything in the list here and click on continue, and let's go ahead and deploy the artifacts. Since I'm doing it quite fast, so that's why the deployment is still successful, and you can see some warnings with respect to the deployment. That's it about the HDI container content management. And next, okay. Now, finally, let's go into the GenAI feature, which is basically helps us in generating the SQL statement by writing the natural language, and which converts into the SQL statement. You can do it by going into one of your HANA instance and open the SQL console. And once the SQL console is up and running, we can make sure if the instance is connected to the right user, and you can select the instance, and it has already been, which shows the current schema and which is connected to the right instance that we have selected to. Let's execute the simple statement, which basically shows us all the tables owned by a current user. So this is the natural language. We highlight that particular statement and click on the option Run Prompt, which takes a couple of seconds and generates the SQL statement based on the prompt that we have written here. And once we have the SQL statement, we can just select the entire line and click on Run. And that would show us the output that we have here with all the necessary data. So that's all about the GenAI feature here, and that's all about the SAP HANA tooling features. And that's all from our side, and we are now open to questions. Thank you.